8 volcanoes, one country, 1 week. In the first 2 weeks of July 2026, Indonesia was simultaneously erupting from 8 separate volcanic centers: Merapi, Semeru, Krakatoa, Lewatobi Laki-Laki, Ibu, Canlaon, Shevaluch, and Dukono, all holding at level 3 alert or above, all producing ash columns, lava flows, or explosive activity at the same time. Magma Indonesia recorded 2,998 volcanic eruptions across the country in 2026 alone. That number was still climbing as of this week. But of the 8, scientists are watching one more closely than any other. Not Merapi, which has been erupting periodically for decades. Not Semeru, which has produced more eruption events in 2026 than any other single volcano on the planet. Krakatoa, the volcano that changed human history in 1883. The one that sits in the Sunda Strait between Java and Sumatra. The narrow bottleneck of ocean through which more than 50,000 ships pass every year, connecting the Indian Ocean to the South China Sea. The one that, on July 2, 2026, was escalated to level 3 alert for the first time since its catastrophic 2018 flank collapse and has been producing explosions, ash plumes, and seismic tremor every day since. This is not a historical video about 1883. It is a video about what is happening right now in the Sunda Strait on a volcano whose behavior in 2018 produced a tsunami that nobody predicted, killed 431 people, and demonstrated that Krakatoa can transition from elevated activity to catastrophic collapse in a matter of hours, without triggering a single earthquake-based tsunami warning. To understand why Krakatoa is the one scientists are watching most closely, you need to understand what it is, not in the 1883 sense, but in the 2026 sense. The volcano that erupted in 1883 and collapsed into the sea, generating a tsunami that killed over 36,000 people across the coasts of Java and Sumatra, is gone. What exists today is Anak Krakatoa, the child of Krakatoa, a new volcanic island that grew from the caldera left by the 1883 collapse. Anak Krakatoa first emerged from the ocean in 1927 and has been building itself ever since, reaching a height of 338 meters above sea level by the time of its 2018 eruption. The 2018 eruption began in the way most Krakatoa eruptions begin, with elevated seismicity, increased gas emissions, and ash columns rising from the summit crater. Scientists were watching it. It was at level 2, elevated unrest, not yet a crisis. And then, on December 22, 2018, at 9:03 in the evening, the southwestern flank of Anak Krakatoa collapsed into the ocean. The collapse happened in approximately 2 minutes. It removed roughly 2/3 of the volcano's mass, 150 to 180 million cubic meters of rock, and generated a tsunami that reached the coasts of Banten and Lampung provinces within minutes. Waves up to 13 meters high struck coastal communities without any earthquake-based warning system activation. The tsunami warning systems in Indonesia are calibrated to detect submarine earthquakes. A flank collapse does not produce the seismic signature those systems look for. The waves arrive before any official warning could be issued. 431 people died. More than 7,200 were injured. Tens of thousands were displaced. Since 2018, Anak Krakatoa has been rebuilding itself from within the new, smaller crater left by the collapse. By 2026, satellite imagery confirmed it had rebuilt to approximately 160 meters above sea level, less than half its 2018 height, but growing. And on July 2, 2026, at 2:05 in the afternoon, it erupted again. A dense gray-to-black ash plume rose 200 meters above the summit. The Indonesian Geological Agency escalated the alert from level 2 to level 3, the standby category on Indonesia's 4-level scale, at 4:30 that afternoon. The 3-kilometer exclusion zone was reinstated around the active crater. The Volcanic Ash Advisory Center issued aviation warnings for ash reaching flight level 40, 4,000 feet above sea level, drifting northwest across the Sunda Strait toward the shipping lanes. Between June 16 and July 2, instruments had already recorded 740 escalation earthquakes, 24 harmonic earthquakes, 247 low-frequency earthquakes, and 520 hybrid earthquakes beneath the volcano. The tilt meter at Tanjung Station showed fluctuating low-scale inflation. The ground was rising, indicating magma moving upward into the system. The shallow seismicity was elevated. The continuous tremor was present. Every instrument in the monitoring network was describing a volcanic system in a state of progressive pressurization. The level 3 escalation has held for more than 2 weeks. The volcano has not returned to level 2. It is not calmed. The daily bulletins from PVMBG describe ongoing explosions, 5 per day, ash plumes rising 200 to 250 meters above the vent, continuous tremor detectable at the monitoring stations. The situation is not improving. It is persistent. Now consider what persistent level 3 activity at Krakatoa means in the context of 2018. The 2018 flank collapse occurred after a period of elevated but not extreme activity. There was no M6.0 earthquake. There was no dramatic escalation in the hours before the collapse. The failure of the southwestern flank happened during what was, by historical standards for this volcano, a fairly ordinary eruptive episode. The lesson of 2018, the lesson that Indonesian volcanologists have now incorporated into every monitoring protocol for this volcano, is that the transition from elevated to catastrophic at Krakatoa does not require a visible precursor. The volcano's structural stability, which depends on the internal architecture of a volcanic edifice that has been built, collapsed, and rebuilt multiple times in the past century, is not something that external monitoring can fully evaluate. What the monitoring can tell you is that the system is pressurized, that magma is rising, and that the flank above the water has not collapsed. What it cannot tell you is when that changes. Stop for a moment. The Sunda Strait is one of the most trafficked maritime corridors on the planet. Approximately 50,000 commercial vessels pass through it annually: tankers, container ships, ferries carrying hundreds of passengers between Java and Sumatra. The strait is 24 to 130 kilometers wide. Krakatoa sits near the center of it. A flank collapse generating a tsunami comparable to 2018 would reach the coasts of Banten Province and Lampung Province within 15 to 30 minutes, before most early warning systems would have time to process, verify, and broadcast an alert. The coastal communities on both sides of the strait have not been fully evacuated during the current level 3 escalation. The ferries crossing the strait have not stopped. The shipping lanes have not been rerouted. The volcano is erupting at level 3, and the strait remains one of the world's busiest waterways. The broader Indonesian picture adds context that cannot be separated from the Krakatoa story. Magma Indonesia recorded 2,998 volcanic eruption events across the country in 2026, as of early July. Indonesia sits on the most volcanically complex section of the Ring of Fire, the Sunda Arc, where the Australian plate subducts beneath the Eurasian plate, generating the chain of volcanoes that stretches from Sumatra through Java, Bali, and the Eastern Islands. The June 8 M7.8 Mindanao earthquake, which struck the southern Philippines on the same subduction system, sent seismic waves through Indonesia's volcanic field within hours. What those waves did to pressurized magma systems already in elevated unrest is something the monitoring data is still characterizing. Merapi, the most closely watched volcano in Java, has been at level 3 continuously and produced lava dome growth visible from Yogyakarta. Semeru has produced 1,344 eruption events in 2026 alone, more than any other single volcano globally. Luatobi Laki-Laki has been in continuous eruption since late 2024. Ibu volcano in Halmahera has been producing daily explosive activity for months. The Indonesian archipelago is, by any measure of 2026 data, experiencing one of its most volcanically active periods in the modern monitoring record. And at the center of the Sunda Strait, between the two most densely populated islands in the world, the child of Krakatoa is building itself back up, exploding 5 times a day, producing continuous tremor, rising on its tilt meters, growing on its satellite images, holding steady at level 3. In 2018, the waves arrived before the warning. The monitoring network has been upgraded since then. New sensors have been installed. New protocols have been implemented. But the fundamental challenge of a volcanic flank collapse, that it occurs without a seismic trigger detectable by earthquake-based tsunami warning systems, has not been solved by any technology currently deployed in the Sunda Strait. The scientists watching Krakatoa are watching the right thing. The question is whether they will see what they need to see in the time they have to act on it. Subscribe to Seismic Alert. We will keep watching the Strait.